All right, welcome everyone, and thanks for joining us to this talk where we're gonna chat with Aaron from Atlassian about how they're using Tecton, Cursor, and MCP to accelerate feature engineering and really ML development overall. I'm Kevin Stumpf. I'm the co-founder and CTO here at Tecton, and with that, Aaron, welcome to this show. Do you want to introduce yourself really quick?
Yeah, sure. Thanks, Kevin. I'm Aaron. I'm a machine learning engineer at Atlassian, working on search relevance. So what our team does is really we're looking to improve the relevancy of search results across our Atlassian products. So if you're in Confluence and you're searching for a Confluence page, we are hoping to bump up the most relevant search results for you and improve that search experience.
Awesome. Are there any other products that you're affecting, or is it
Yes,
primarily Confluence?
I'm glad you mentioned that. So not only Confluence, but we're doing Jira and things like Loom and Trello, and also third-party products now, Slack, G Drive, all of these types of things. You should be and Rovo. I should mention Rovo. So all of these products you should be seeing results for in the search stack, so any of these pages that you're looking for, we will show you. Yeah.
Cool. Do you mind maybe explaining to the audience really quick what Confluence and Rovo are? Who uses them for what? For those who are not familiar with.
Yeah. So Confluence is our sort of wiki document product. So, if people are making blog posts, wikis, how-tos, run books, all of these things exist on Confluence. That's what our customers are using Confluence for. And Rovo is our new LLM chatbot capability that will answer your company's company-specific questions for you using your proprietary data. So if you onboard to Rovo and you connect your Confluence, but also you can connect your Slack and you can connect your third-party products and Jira. And so if you ask Rovo a question, say, hey, what are my work items for this week? It should answer that question for you in plain English and look for all of your Jira tickets and everything across your workspace.
Got it. So can I think about it like almost like an internal Google search over all the different internal documents that I've got in my Google Drive, in my Jira,
yes,
my Notion, whatever else I may be using?
Exactly. Yeah, that's a great way to put it. Sort of your internal RAG system lives with Rovo. Yeah.
Excellent. Cool. And what are you personally responsible for?
Yeah, so as a machine learning engineer, I am sort of currently responsible for computing a lot of these features that are going into these models that feed our search stack, right? So beyond just semantic relevance, we're talking things like title match and keyword match. But beyond that, we want to look at behavioral signals also. So features like popularity, freshness, social signals, authoritativeness, recency, all of these sort of features, are impactful to the relevance of a certain page. So if a certain page is getting a lot of views at your company, we certainly want to rank that higher. So we're using Tecton right now to sort of to reach out beyond just semantic relevance and semantic similarities to capture more of this behavioral signal. And we are iterating quite quickly on rolling out a lot of these features thanks to Tecton.
Got it. Okay, so you're responsible for picking upstream raw data sources and then transforming the raw data into relevant features, signals that then get fed into the search ranking, re-ranking, etc., personalization, ultimately machine learning models that feed the search algorithms in the different products.
Absolutely. Exactly that. So we have, bunch of different data sources, including, event data, click data, and we are computing these features, running experiments with these features, seeing how they perform online with our customers, and then rolling those models out to production when we see metric lift. Yeah.
Cool. Are you also responsible for training the models, or is that a downstream team or someone else on your team who's working on that?
Yeah, it's someone else. We're all sort of in this together. So we calculate the features, we train the models, we experiment with the models, and we have a few different models that run that are tuned to product specific. So we have Confluence models and third-party models, Jira models, and all of those features are unique to those models that we compute. And yeah, so we previous to Tecton, we had a few different ways of calculating these features. No one real master way of doing it. And now that we are with Tecton, we are moving towards having one sort of centralized feature store where we serve up a lot of these features, and we can keep our this search stack code sort of geared towards just towards Tecton, and the semantic piece run separately. But
cool, awesome.
Yeah.
Can you speak a little bit about the different types of almost archetypes of features that you work on, that you develop, that feed into those downstream models without revealing any trade secrets?
Yeah. So one feature that we really had success with recently, no shocker here, but page popularity for Confluence. So things like page views, has brought us a lot of lift. And so this is something that Tecton is a perfect use case for, reading in event data, where we see, hey, here's a page view event, and we can aggregate those over certain time windows. So we like to see, hey, how many views did this page get in the last one day, the last week, the last month, the last year? All of these bring signal, and then we can also normalize those raw view counts based on the size of a customer, and so that really helps. A smaller customer, one or two pages on a page, one or two views on a page might mean a lot to that small customer, as opposed to a bigger company where that would be an unpopular page. So that's one that's really brought a lot of lift. And then signals like recency. A user, if a user viewed a page, viewed a specific page in the last month or the last week, we want to rank that page higher than pages that maybe that user hasn't viewed at all. So yeah, those are two that's brought a lot of lift. And then just things like freshness of pages and issues and things like that. That's all very important. We're working on those features now also.
Are those all batch computed features, or do you have streaming and real-time computed features too in there?
Yeah, we do. We have both. So the popularity, I think we run as batch features, and for things like freshness, I think we have those as real-time streaming features. We want to know, if you created a page in that day, and we want to rank that page the day that you made that page. So we have that as a streaming feature also.
Cool. Awesome. And before we talk about how you're using now Cursor and MCP and whatnot to accelerate the feature development, I'm curious if you can just briefly explain why you guys ended up choosing Tecton and how are you using it really to do the feature development?
Yeah. So our favorite feature about Tecton is the point in time accurate historical offline store. So when we're generating training data to train these models, it's really important that we have point in time accurate feature values. So if we're training data that might have come from the first 3 months of 2025, we want to know in February of 2025 how many views did this page have that might have led to a successful click or successful search session. So that's really what Tecton excels at. And then on the flip side, the online feature store having low latency for our search sessions to we have a set of recall documents that come from the search index, and then we want to have feature values fetched for all of those documents in really low latency, so we can deliver those results as quick as possible. And so we get really low latency from the Tecton online store. And so, those two things really make it very attractive for us to use.
What latency do you need?
It depends. There's a lot of things that happen in the search stack, but that sub 100 milliseconds is always what we're shooting for. I know we've worked to get some of our features down to even sub 50 milliseconds. I think some of our batch features are running close to like 30 or 40. And so these are all considerations that we make when we're doing our feature definition and feature design, tweaking little things in the batch, aggregation intervals or batch schedules or look back windows. All of these types of things go into to reducing that latency.
Got it. And really quick, before I move on to the cursor section, I'm curious if you can explain to the audience the broader tech stack that Tecton plugs into. Like, where do you actually train the model? Where do you deploy and host the model?
Yeah. So our model training and data storage all happens in Databricks, and then our model hosting lives in SageMaker, and then we're calling Tecton through the HTTP API to fetch those feature values.
Got it. Okay, so the training side is then mostly consisting of Tecton plus Databricks, and then the online real-time inference side is all Tecton plus SageMaker.
Yeah, exactly.
Excellent. All right. Then I'm curious if we can talk a little bit about how you now actually do feature engineering. I know you guys are using Cursor. You've been early adopters of actually leveraging AI to get more efficient, productive. If you just tell us a little bit more about how you've been using it so far.
Yeah. So for anyone who's used Cursor knows that it's a very handy pair programmer. Just at its base, without a MCP server, it's pretty good at making Google searches to look something up if it doesn't know. But yeah. So now, as we're building out a lot of these features for the search stack that I mentioned earlier, we're iterating pretty quickly to bring feature parity between all of the different models. So what exists for Confluence, we want to have for Jira, we want to have for 3P. So this is a lot of, this would be a lot of code to write by hand manually, but having Cursor, understand the feature definitions or the architecture that we or the folder structure that we have in those repos is really helpful to crank out these features really quickly. But now with the MCP server, you really have a pair programmer that knows a lot about Tecton specifically at your fingertips. So things like if I'm looking up something in the SDK, or I want to know the best practices about something, or I want to see, hey, what's a code example of how this option is being used? All of these types of things, the MCP server does really well. And then writing unit tests is something I use it for a lot also. So if I want to quickly jot down some use cases that I want to have included in the tests. I can ask Cursor to write those tests and cover those test cases. And it always does like a pretty great job, gets you 95% of the way there most of the time. So it's been really useful for me as a feature developer to get these features up and running in the online feature store and ready for experimentation. It's really brought down the time from feature ideation to A/B testing from maybe even a couple weeks to just a couple days. So it's certainly boosted my productivity tremendously.
Awesome. Were you developing Tecton features with Cursor without Tecton's MCP server before, and then later on you added the MCP server? Yeah, you were.
Yes.
Is there like a difference that you can speak to how it changed by layering in the MCP server?
Yeah. So previous to the MCP server, Cursor would really rely on existing feature definitions in the repo. And it's just more prone to hallucinations without the MCP server. So, you could ask it a question about a best practice, and it would look maybe into a existing feature definition in that repo and very confidently tell you, hey, this is the best practice because this is what I see in your repo already, which of course isn't always the case. We have some test features in there, some old features in there, maybe some hastily written features that aren't being used in production that exist in the repo if someone forgot to clean it up, and those can cause a lot of hallucinations from Cursor. But yeah, having the MCP server, Cursor is going to call that tool or make a call to a certain tool in the MCP server, make sure that it's referencing the correct documentation, make sure it's referencing approved code snippets that you guys have built for it. And so this like really reduces the amount of hallucinations that the model makes, and is able to just sort of get into a dev loop that's a lot cleaner and just a lot shorter distance to creating a successful Tecton feature as opposed to just relying on Cursor.
That's cool. Yeah. It's interesting how ultimately the more relevant the context is that it can provide to an LLM as it's trying to work its way through a question, the more you can reduce hallucinations. But typically you cannot get them down to zero. Like you can get them closer to zero, but not get them all the way down. So I'm curious, how do you handle the remaining few instances of hallucinations that come up?
Yeah. So I think it's important for any developer who's working with any of these AI tools to not trust 100% of what is getting generated. I'm sure we'll get there in the next few months or years, but right now it's important to just look over any code that gets written by Cursor. Don't just trust it blindly, and just having experience writing Tecton features before the MCP server was really helpful. I wrote a few features even before having Cursor, just in VS Code and having to read the documentation myself. So I already had a great understanding of Tecton, how a lot of these mechanisms work, like the aggregation engine, sort of the look back windows. A lot of these things I already had an example of. So if something hallucinates in Cursor, or if Cursor hallucinates about anything that I see, like, okay, that's a little fishy, I could press it harder to say, hey, are you sure? I think you should look up the documentation on this, specific thing, maybe a little deeper. So it still happens once in a while, but it's much less than it was the previous. Like the hallucinations are a lot less than just using Cursor plain. Yeah.
So one big validation that you do is ultimately use your human eyes and human brain to validate. Is there anything else, like you use unit tests or
Yeah.
or anything like that to automatically like create some sort of a feedback loop and feedback cycle, or is
Yeah.
it? Yeah.
Yeah. So you can allow cursor to well, you can prompt it to say, hey, when you're done writing this feature view or this unit test, please run a Tecton plan or a Tecton test. And if there's any errors, can you go ahead and fix them? So you can write all of this in your prompt, and with an adjustment of some cursor settings to have it auto run. But yeah, you can get into a dev loop where it maybe writes a feature view, it writes a test for it, it runs a Tecton plan, and if there are any errors that get risen, you can have it fall into a loop where it corrects those errors. So that's a nice thing about Tecton plan also, is that it will catch a lot of those things early on before you do an apply to your workspace. And yeah, the other thing is it's really helpful to specify a use case when you're writing, like a test case when you're writing tests, because yeah, if you ask it to just write tests that pass, I've seen it sort of just make sure, hey, is there a test for is there an owner email there? Okay, is there a did we import this correctly? Like things that don't actually reflect the functionality of the feature at all. And those tests will pass, of course, but if you do prompt it to test certain use cases and make sure that your mock data or whatever you're using is correct, that's sort of an important piece to stick a human in the loop.
I'm realizing I've been asking a ton of questions. Maybe it will be interesting to actually switch over to Cursor. I know you prepared a little demo, so you can actually show how this all works in the real world.
Yeah, let's do it.
Cool, I can see your screen. What are we looking at?
Okay, so yeah, so for this demo, I prepared just a mock data source that we could use, a couple entities, and these are things that we do use at Atlassian. So Confluence content and a Jira issue and tenant, which you think of it just as a customer, and yeah, so I've already asked it to create a few of these features, and it does a pretty great job right off the bat. So let's maybe ask it to write us a new feature.
Cursor created features, or did you write any of them yourself?
These are all Cursor created features, so I could just show you ones real quick. So this was I asked it to create a feature view for unique users who viewed a page over some aggregation windows. So we have a nice description, aggregation of unique user IDs viewing Confluence content over the 730 and 180 day windows. You see it defined these features as aggregate features. So this is also intended behavior to use the out-of-the-box Tecton aggregation engine for this feature view. And I asked it to have a batch schedule of 1 day and a feature start time of beginning of the year 2025. Cool. And a few hallucinations, or not hallucinations, but things I would go ahead and adjust as a human in the loop are these tags and the owner here. It has some placeholders, but a very simple and correct SQL representation of this feature. And so this is a very simple feature, but it does a great job of just making that that first draft. And if I go in and I can then adjust some things that are, specific to Atlassian or yeah, just compute options, things like that. Get a little into the nitty gritty. But as a first draft, this is really great.
Cool, awesome. Do you want to show us what it looks like when you create one from scratch?
Make sure I copy paste this. Okay, we're back to Claude. I'm gonna paste my my prompt in here and then ask it to leverage the MCP server. Let's see if Claude is awake.
Oh, that looks pretty good.
That was pretty good. Okay, perfect.
All right, and now it's calling the MCP server from Tecton. Which tools is it invoking?
So it's called the code snippet tool twice and the documentation index tool. So I think, yeah, it is interesting with these reasoning models that it will call the same tool multiple times, perhaps with just like new context every time.
Actually, good. Let's see what the difference is between the two calls. Examples of a batch feature view and of aggregations. Okay, seems reasonable. Seems like what you'd expect a human to do.
And then documentation index, how to create batch feature views with aggregations.
Nice. And now it's looking through the existing code base, trying to follow some best practices. Excellent. Well, we're waiting for this to complete. I'm curious, like, as it's doing its work, what do you typically do? Like, do you wait until it's done, or do you sometimes find yourself multitasking and having agents work on multiple tasks at the same time?
If I'll probably go and do something else maybe on the side, respond to some Slack messages, but I've never had, in the same session or multiple agents running different things.
Yeah, I'm a fan of like Codex, OpenAI's remote coding agents. And I know Cursor added that capability now too. I think it'll be cool when in the probably pretty near-term future, we can just fire off all these different tasks that different background agents are working on. And we just take a look to see if they did a good job or not. So we're moving out of the single-threaded nature of our work today into more of a multi-threaded one. Oh
yeah, I'll have to look into that. That would be handy for this. I have a large backlog that needs to that we need to work through. So yeah, cool. So this is looking great. We have a Confluence comment and reaction feature here now. We'll just accept and we'll take a look. And it's running the Tecton plan over on the side here. Yeah, these warnings are just from some old tests that I wrote, but great. Okay, so we can see that there were no errors with that plan. We have create the batch feature view. Can ignore some of these older ones, but yeah, perfect. So let's take a look at the feature that I wrote. Let's see if it's doing what we want. So total comments and reactions on Confluence content over the aggregation windows. It's got our correct entity, correct data source, aggregations of comments, or aggregations of reactions. Okay, so this is actually a little bit of a different feature design than I intended, but that's probably my fault with the prompt, right? This is aggregating reactions and comments separately, but it's doing that correctly, at least. So we have case one event is comment created, then one. Case one event name is a reaction, then one as a reaction event. So this is interesting. This is just like a great example of it misunderstanding my intent because of the prompt, but I'm going to go and take a look at the feature definition that it wrote and ensure that it's correct. So you know what? Maybe this is still a handy feature to have. We'll leave it like this, and now we can. I'm not going to apply that. Why not? Let's run Tecton apply. We can get this into our.
It looks like it hallucinated a parameter, auto approve.
Yeah.
And no, it executes it the right way. Just pretty aggressive that it was just suggesting, yeah, let's just go with auto approve.
I wonder where I got that from. Yeah.
That's hilarious.
And then, so maybe we can ask it to write some unit tests next.
Let's do it.
While it's working on that, I can work on a prompt here. Just give it some affirmation that it did a great job. You to.
Yeah, I heard that 4.0 performs better when you're really encouraging to it.
Yeah. Some positive reinforcement never hurts. Please at least test the primary of aggregating comments and reaction counts accurately over the aggregation windows. So I'm just giving it an idea of what the test cases are that I want, right? So I don't care if it has a batch schedule or something. I just wanted to test that it's aggregating the counts of these things correctly over the aggregation windows.
Makes sense.
When you are finished, please run a Tecton plan and address any errors. Okay. So again, this is another example of a pretty bare prompt. It's always better to over describe things in your prompt. But just for the sake of time and to show what this is really capable of, I'm just going to leave it pretty bare and see what it comes up with.
Sounds great. Let's see how much capacity we're able to run on. It'd be really nice if it showed us some little indicator of how overloaded the different models are. Expected queuing and wait times for them.
Cursor's a little black box when it comes to that stuff. Also, I'm hoping that this that it recognizes that it has some rules around writing unit tests, which Sonnet has in the past without me having to prompt it to do so. Okay, so I'm giving it the Python file with the feature definition as context, and I'm asking it to write some unit tests, reminding it of its rule that it has. So it is following this rule, and now we're going to make some MCP calls.
Excellent.
Okay, it's created a test file with two test cases, one testing the comments and one testing the reactions. I'm sorry, no, the one testing comments and reactions and one testing an edge case of having empty data. Let's run the Tecton plan and see if it catches any errors here. Okay, so we do have some errors in this test. Let's see if it can catch it.
So now it's running in a loop to try to address them autonomously hopefully without requiring your input.
Exactly. So it's caught the error just about a misnamed column. So yeah, missed instead of tenant underscore ID, used tenant ID camel case. And we'll run it again. While it's doing that, we can double check what these tests actually did. So
Looks
you
like
can see it followed the rule of using the test repo.
Looks like it was able to fix one of the tests. And what's also interesting is like we're using 3.5 now, given the capacity issues of 4.0. And like I found 4.0 to do a better job vibes-based than 3.5. And it oftentimes gets things just a little bit faster than 3.5.
Yeah, no, totally. And I think the reasoning of 4 gives every iteration a better context.
Yeah.
It seems like the context is the window of it's a lot shorter with 3.5.
Good point. Yeah. All right, let's give it one more run, and then I think we're running short on time here.
Yeah. But regardless, this is regardless of if the test passed here, it's a pretty great first draft of some tests that I can then go in and adjust. But just the fact of it's creating some dummy data, create test request events, and then calling the get features for events. These are all things that we would want to have in these unit test files.
Yeah. Let's see if it is able to fix it now. If not, that ends how are you using Cursor, how are you using the MCP server. Let's see, let's maybe summarize with some takeaways, like how, when you step back, how would you describe just what are the key benefits that you're really getting from Cursor, from AI coding agents, and from the MCP server?
Yeah. Well, yeah, to start with just Cursor and agents, the main benefit is productivity, right? It takes me a lot less time to write these features instead of every keystroke being by hand or just blindly copy and pasting from old feature definitions. I can prompt, I can have it sort of write a lot of the boilerplate for me, and then most of my time is spent just editing, right? And so this actually takes a lot less time than writing everything by hand, or even copy pasting and then editing from there. So that's really helpful. And it does a great job of writing Tecton feature definitions. It does an okay job what the MCP server really is excellent at is being this like pair programmer who understands a lot about Tecton specifically, and is able to follow those best practices. Even writing unit tests for Tecton has some specific quirks, like this test repo fixture is something specific to Tecton that Cursor probably wouldn't have picked up on. So having these rules and tools is just really kind of shrinks that time from ideation to having a solid feature that I can now test. So yeah, my productivity has boosted a whole lot because of this.
Awesome. Well, thanks so much, Aaron, and thanks everyone in the audience, and thanks for posting all your questions. We've been trying to answer everything we can in the chat, and if we missed anything, then we'll definitely try to get back to it later. And with that, enjoy the rest of the Apply conference. Thank you all very much.
Hi, folks. Thanks for hanging in with us. We're going to keep it rolling here in a few minutes, but feel free to stretch, go get coffee. When we come back, we're going to jump into a session about using sequence features for fraud detection with Tecton and AWS. So stay tuned to that. We'll get started in just a few minutes.